right, so the next topic, we just got done doing all of our function stuff, which we need to know moving forward. Next topic that we are looking at is linear functions. Basically, going back to Algebra 1, can you write the equation of a line? Can you read a word problem and come up with an equation for it? So that's what we're working on here. So we're just going to jump right in with the problem because I feel like, do you guys know what's the equation of a line look like? Okay, good. We remember that, and we know a line, what a line is, straight. Yeah. Okay. We don't need to go back that far. So as dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of the height h in kilometers, assuming that a linear model is appropriate. All right. That's a lot of words, wasn't it? So what information do you need to write the equation of a line?
The slope.
We need a slope.
And the intercept.
And the y-intercept, okay? So, did I tell you the slope and the y-intercept here? Okay. So what else can we do? How do I get that stuff?
Ax
it's
plus,
like
no, not that.
something
X1
over something
over-
equals.
Oh.
y1 over x.
X2 minus
y.
Change in y
I was close.
We were
over change in x.
Yeah, I used to have the
Remember finding slope?
Yes.
Okay, so we need ordered pairs to do that. Here is the place where people most often make their mistake in these problems. It's in writing your ordered pairs. Because technically, x and y could be flipped, right? But I am telling you what I want them to be because I'm telling you to express temperature as a function of height. So the temperature is my function. So my temperature is a function of the height. So the temperature is our y. And that means height has to be the x. So I'm telling you in these problems which one I want. The function is always your y. So when you see t as a function, I know that is my y variable. So now using that, we can write our ordered pairs. The ground temperature, so I need the height. If you're on the ground, what's your height?
0.
And your temperature was? 20 degrees Celsius. And then the height of 1, the temperature was 10 degrees Celsius. So now I have my 2 points, so now it should be easy, right? We do our y2 minus y1, so 10 minus 20 over 1 minus 0, and we get negative 10. All right, so technically, in this problem, I did give you the y-intercept, but you may or may not catch it. What is the y-intercept? 20. Why?
Because it's the ground that's 0.
Y-intercept is where you touch the y-axis, so your x is always 0. So if you realize it, I did give you the point where x was 0, so you have your y-intercept. If you didn't catch it, how would you find your y-intercept? We have two options. We can either do the point slope formula, like y minus y1 equals m times x minus x1, or plug into y equals mx plus b. Which way do you guys usually use? Do you remember? I don't really care, but I didn't know if you guys had a class preference. Did you do point slope formula a lot? Seems like, I think something in the way Mrs. Keller taught it switched, because for years and years everybody was always y equals mx plus b, and that's the only thing they would do. And last year I had quite a few people that liked the point slope, so I don't really know which one you guys prefer. But if you did y equals mx plus b, you just take one of your points. Your y was 20. We got our m to be negative 10. The x was 0 plus b. So 20 is our y-intercept, and we get it that way as well if we didn't catch it before. All right, technically, I did give you the variables. I didn't really say to use x and y, I said to use t and h. So temperature was my y, equals m times my x, which I said to use h, plus our y-intercept, which is 20. If I don't tell you the variables to use, you can certainly do x and y in your equation, but it shouldn't scare us too much to use different letters. Is that okay? So we just wrote the equation on the line. But here's where the fun part comes. I'm going to ask you to interpret something. What does the slope represent? So think about how we got slope. It's a rate of change. We did y over x. What was my unit on y? A division is like per. And what was my unit on x? Okay. So it's asking us to interpret. So we need units. We also need to use the slope number. So negative 10. What does a negative tell me? So it's falling negative 10 degrees Celsius per kilometer. So the temperature falls 10 degrees Celsius for every kilometer the height increases. So if I'm asking you to interpret the slope, you should use both the number and units in that sentence. Think of it as like a negative is the falling. It was 10 degrees Celsius over 1 kilometer. So it falls 10 degrees Celsius for every 1 kilometer your height rises. Does that make sense to them? Next question. What is the temperature at a height of 20 or 2.5 kilometers? So what do I do? T is equal to negative 10 times 2.5 plus 20. Okay, we're checking our non-calculator skills. Multiply by 10, you just move your decimal, right? So negative 25 plus 20. We get negative 5. What would my units be? Questions on that one? I want you to read the next one and try to do part A. We'll check your equations before you go too far. Okay, so let's. So it tells us Jason leaves Detroit at 2 p.m. and drives at a constant speed. He passes Ann Arbor 40 miles from Detroit at 2:50 p.m. Express distance traveled in terms of time elapsed. Okay, so which one is my y and which one's my x? Y is always in terms of x. So time is x, distance is y. Did I give you certain variables to use here? No. So if you want to use d and t, you certainly can, or we can use x and y, whatever you guys like. But I need ordered pairs if I'm going to do this. And the ordered pairs are a little less obvious than the original one, aren't they? So we start at 2 p.m. and we're ending at 2:50. So that's my time. But do I want to use like 2 and 2:50? No. What would I use for my starting time then?
0.
Yes. And we end after 50 minutes. So this, my time is in minutes, the way we're setting this up. Okay, so if I begin, what's my beginning distance?
It's even.
All right, we start at 0, 0. And my ending distance? 40. Good. So now we can do our slope. Changing y, we're changing x. y2 minus y1, or x2 minus x1. 40 over 50 reduces to 4/5. Do I need to find my y-intercept? No, I'm given that already. It's when x is 0, your y-intercept is also 0. If you didn't catch that, just plug in y equals mx plus b. It'll take you 10 seconds tops and quick check. So do you want to use x and y or d and t? X and y? So y equals 4/5 x would be my equation. Okay. Interpret the slope. So think about what we have. We have 4 over 5. What's the unit on my 4? That came from my y. Careful though. My time, 50 was minutes. Now, could we have converted that 50 minutes into hours and gotten it in terms of hours? Yes, we just didn't. So what does this mean? How would I interpret that? Exactly. Drives 4 miles every 5 minutes. Could you say he drives 4/5 of a mile in 1 minute? Yep. So there's not just a clear right or wrong on these. Lots of ways you can state the same thing. C. If he continues to drive the same speed, how far will he have driven by 3:15 p.m.? So now we need to think. We measured our time in minutes. We started at 2. How many minutes does it take to get to 3:15? So that means my time is 75 minutes. So if we plug that in, well, you could do 75 divided by 5 if you wanted. That'd be 15. 15 divided, or times 4 would be 60. What are my units? It's just, we are finding only distance, so just minutes. Now, keep in mind, like, this one wasn't so bad, but in general, I don't make my class examples all nice, pretty numbers, so you can use a calculator in class. You know, your homework, you're probably gonna need calculators sometimes. It's a lot of effort to make problems that work out nice. I just don't do that all the time. You need to know not everything's pretty, so. All right, is that okay? You guys think you can try another one? Try setting up this one. All right. The manufacturer, or the manager of a furniture factory finds that it costs $2,200 to manufacture 100 chairs in 1 day, and $4,800 to produce 300 chairs in 1 day. So express cost as a function. So which one's my y? Y is always a function of x. So when it says cost is a function, your cost has to be your y. Then that means the number of chairs is x. Did you do it right after all?
I just heard you wrong. I'm sorry.
I don't know. Did I say it wrong?
No, I think I just heard you wrong.
Okay. So the cost is the function, so cost has to be the y when we set this up. Did you guys use x and y as your variables? Okay. It didn't tell us to use certain letters, so that's fine. So we need our ordered pairs. So the number of chairs is x, so we know 100 chairs costs how much? And my second ordered pair, 300 chairs cost. So then we do our slope, y2 minus y1 2 minus x1. Use your math tricks, mark off zeros. 26 divided by 2 is 13. So we get 13 for our slope. Do we know the y-intercept this time? No, so we actually have to work it out. So you pick one of your ordered pairs, plug into y equals mx plus b, or do the point slope formula like y minus 2200 equals 13 times. The way you're looking at me, you guys don't do it that way. Okay. Plus b, subtract that over, so the y-intercept is 900. So our equation is y equals 13x plus 900. B, interpret the slope. So think of this as a fraction for a minute. If this were 13 over 1, 13 is the y. What did y represent? And what did the x represent? So what does this mean? Think about, like, in manufacturing, you have like your startup costs as well, or like your building, that kind of thing. So you only pay for that once, no matter how many chairs you make. That's actually where we're getting at with part C, our y-intercept. Okay, part C. This time it asks us to interpret the y-intercept. My y-intercept is 900. That means it's like a point, 0, 900. 900 is my cost. My 0 is the number of chairs. So what's this telling me? So a lot of times those are referred to as your fixed costs. It's things you have to pay no matter what. So depending on scenario, it might be the cost of our building, turning the lights on, hiring a worker to come in. Like if somebody's scheduled to work, even if you don't make any chairs that day, you still have to pay them. So there are lots of things that can go into that number. So lots of ways you could describe it. So you could say it costs $900 without producing a chair. You could say the fixed costs are $900 or the operating costs are $900, any of those kinds of things. All right. Is that okay? And let's stop there.